Hi everyone, in this video we will be going over operations with scientific notation. Our essential question for today is, how are the operations used to evaluate problems that are in scientific notation? So once again, how are the operations used to evaluate problems that are in scientific notation? And just a reminder, operations are when we're talking about adding, subtracting, multiplying, and dividing. So first we're going to go over multiplying and dividing with scientific notation and how to find the product and quotient when we are multiplying or dividing in scientific notation. Now, although that it may seem weird to start with multiplying and dividing rather than addition and subtraction, multiplying and dividing is actually much more simple. So we're going to start with the easier part first and then move into the little bit more difficult part. Okay, so the steps for multiplying and dividing scientific notation are first to multiply or divide the coefficients. So think back to when we have something in scientific notation, such as 4.5 maybe times 10 to the 6th. Okay, remember this is the coefficient, and then this is our power of 10. Now, when you're multiplying or dividing, you're going to have two sets of this that you're either multiplying together or adding, or dividing. And your first steps are to multiply or divide these coefficients that are right here. Then your second steps are going to be to add or subtract the exponents to be able to get your power of 10 up here. And then finally, you want to write your answers in scientific notation. So this probably sounds very strange to you right now, but once you start to see the examples, you're going to see it's pretty easy. Okay, so first example, we can see it's asking us to multiply, and we've got positive exponents. So when we say that our first step is to multiply the coefficients, we're talking about these numbers right here. And really what you can do is you can separate these ones from your powers of 10. You can combine them separately, because when you're thinking about multiplication, again, it is commutative. It means whatever order you multiply will work. So what I'm going to do is I'm going to instead move my parentheses around and put the coefficients together. So I'm going to move them down here, and then I'm going to put my powers of 10 together. Okay, now you can use a calculator to be able to do this math because it will make your life a lot easier. So you will need a calculator to do this part right here, the 3.48 times 9.8. However, when you look at your power of 10, this is the product rule, and the product rule says that you add the exponents and you keep the base. So it stays at 10, and 3 plus 4 will become 7. So once you use your calculator, you would get this answer right here, times that 10 to the 7th, because remember, product rule says add the exponents, and we get 10 to the 7th. And to start getting this in scientific notation form, we can kind of separate it now. Instead of using the parentheses, we can use that times sign. But this is a problem right here. As you can see, that's not in scientific notation. We have 2 digits to the left of the decimal. We need to get it to where we move the decimal over one place, so that way that number is between 1 and 10. Now when we do that, this number becomes smaller, and I've got a couple of hints over here that I would highly suggest writing down. But what it says is that if your coefficient becomes smaller, so that's the one we're talking about right now, so if your coefficient becomes smaller, your exponent becomes larger. And that makes sense because when you're moving the decimal over here to make it a smaller number, that means this power of 10 needs to grow. It needs to be larger to account for that number becoming smaller. So if this becomes smaller, you've got to make something else larger. So when I move this decimal place over 1, this exponent right here is going to go up 1. Now to finally write this, and I don't think I showed it here, in your homework, I want you guys to write it to the tenths place. So the final answer when you write this would be 3.4, because that's what it rounds to, times 10 to the 8th. And I'll be specific on there on when to round, but there are a few problems that you might get where it goes to a lot of different place values and it doesn't end. So rounding is going to be your best option. Okay, so as you can see, not too bad. Now let's look at one with negative exponents. So again, let's separate our coefficients from our powers of 10. And we're just going to kind of separate those out. So I've got 2.32 times that 6. So I separated our coefficients, and then I separated our powers of 10. Now again, use a calculator to multiply. And over here, we've got the product rule. So it says add your exponents. So negative 6 plus negative 5 will be a negative 11. So once this is multiplied, we get 13.92 times 10 to the negative 11th. And to start getting that in scientific notation, we can separate it with that multiplication sign. But again, look at this. This is not in scientific notation because this is too big of a number. It needs to be between 1 and 10. So we're going to make it smaller, which is going to make this exponent larger. Now, this is what will trick people. This is so important right here, okay? I'm going to make some more stars all over this page. This is so important when you're thinking about negative exponents. So write this down. Think about the fact that if you're going to make this exponent larger, it needs to get closer to 0, okay? When you think about your number line and you've got negative 11 and 0's over here, a lot of people will say, oh, negative 12 is larger than negative 11 because 12 is bigger than 11. But that's not true in negatives, right? If I owe someone negative $11 and then now I owe them negative 12, that means that's a lot more than I'm owing. So when this, I'm saying, needs to become bigger, it needs to get closer to 0. So instead of it being to the negative 11th power, it's now, once we move this decimal, going to become to the negative 10th, because that's going to be a smaller decimal. Okay, so negative 10, remember, is bigger than negative 11, which is why when this coefficient became smaller, our exponent became larger. All right, so dividing is very similar to multiplication in the sense that you are just going to separate your terms. So the first thing you want to do is really you're kind of just drawing a line down here and saying, okay, I'm going to divide these, and then write in scientific notation. So this is kind of what it looks like when you separate it out. It helps you to visualize that there's a separation here. And again, use a calculator on these. It's going to make your life easier. However, on your powers of 10, you need to use what rule? Think about it. You've got division, so that is the quotient rule. And the quotient rule says that you simply subtract your exponents. So use your calculator to divide here, and then your power of 10, you just subtract your exponents to get the combined power of 10 together. So once we divide, we get 0.866 times 10 to the 5th. Now, what you again see here is that this is not between 1 and 10. This is actually smaller. So before, we were looking at examples where the number was larger. This time it's smaller. So if you look over here, if your coefficient needs to become larger, okay, then your exponent is going to become smaller. So this needs to become larger, which means I've got to take something away from somewhere else to account for this becoming bigger, and I'll take it away from this 10 to the 5th. So if I move this over 1 to right there, and it becomes 8.6, this is going to have to move down 1 since this became bigger. So it becomes 8.6 times 10 to the 4th. So this became smaller, and technically if we rounded more correctly, this should have been 8.7, right? Would have been a little bit more accurate. Okay, now let's look at one with negative exponents. So again, you want to separate your terms. Now I have to be honest that I think that the negative exponents are where students tend to have the most things go wrong, because they kind of forget their integer rules. So it's very important that you remember those integer rules when you're doing this. Now use a calculator to solve this part right here. Okay, very simple. But right here is where a lot of students are going to mess up. Okay, because this is the quotient rule and it says to subtract these two numbers. And a lot of people say, oh, well, that's 0. That's 10 to the 0 now. But that's not true, because think about your exponents. You got negative 6, and you're going to subtract that from 6. Okay, so negative 6 minus 6, though, isn't 0. It's a negative 12. So once we divide this and get that number, our power of 10 is going to be to the negative 12, not 0. Be very, very careful on that. Okay. Now again, this number is much smaller, and you'll see this happen a lot sometimes when you're doing the division problems. And it needs to become larger so that it's between 1 and 10. So if I move this over 1, and this number is becoming larger, this exponent has to become smaller. So for it to become smaller, it's going to need to get farther away from 0 this time, which means it's going to become a negative 13. Because remember, that's smaller than negative 12. Even though the number 13 is larger than 12 when we're talking about negatives, that means it's smaller. And as you can see, we just rounded up here. We just rounded that. Once we move that decimal over to become 3.06, we just changed it to 3.1 to round it up. Okay, now I think multiplying and dividing is your most simple one because it's just using very basic multiplication and division and exponent rules. Adding and subtracting tends to be a little bit more complicated, but I'm going to show you two methods. One which I think saves you time but might be a little bit of a difficult concept sometimes, and one that takes longer but is a very easy concept. So you can kind of choose which way you want to go with that. Okay, so your steps for adding or subtracting. Your first step is to increase the smaller exponents to the same number as the larger number. Before, when we had different exponents, we could use the product and quotient rule to be able to simplify it. You can't do the same thing with adding or subtracting. All your exponents need to be the same. You're going to have to move the decimal point of the number with the smaller exponent to the left, and then add or subtract the coefficients. So I kind of go through this a little quick right now because I just want you to write them down. That way you have the steps and you can look at those steps as we're going through these examples. And then finally, write your answer in scientific notation, of course. Okay, so let's look at an example. Oops, and this looks like it there we go, kind of skipped. So when we're adding, the exponents have to be the same for you to be able to combine it, okay? It's very different from multiplication and division. So our goal is let's make all the exponents go up to the largest one. Now think about this one right here. We've got 10 to the third and 10 to the fourth. So we're going to make this, we want this one to go up. And think of this rule over here. If we want this number to go up, it's almost like the opposite has to happen to this. So if this exponent goes up, this is going to go down. So it basically just does the opposite. So not too difficult of a concept. And when I say it gets smaller, that means you're just going to move the decimal over one place. So instead of 3.48, it's going to become 0.348 to the, and then times 10 to the fourth. So since this exponent got larger, this coefficient had to get smaller, and this stays the exact same over here. It was perfect. Now, once your exponents are the same, this gets very simple. All you have to do now is add your coefficients, and your 10 to the fourth just stays the same. So you can see all I did was I brought these coefficients down to say we need to add them, but since these are the same, they just stay times 10 to the fourth. Because when you're talking about product or quotient rule, yes, we need to combine it and we need to add those exponents. But remember, product and quotient rules, those only apply to problems of multiplying and dividing. When we're talking about adding or subtracting, that 10 to the fourth just stays 10 to the fourth. So then from there, you simply add it together. And if you look at your answer, again, we've got a problem that this is not in scientific notation. So we need to move the decimal over one place. Now, if this gets smaller, then this has to get larger. Okay? So if this becomes 1.0, once I round it, then this has to become, the power of 10 has to become to the fifth power. So again, this became smaller, our coefficient became smaller, so our power of 10 had to become larger. So as you can see, it's not too bad. It's just a little bit more steps. Let's try one with negative exponents. So again, we want to get these to be the exact same exponent. And honestly, it could either go to -5 or to -6. It's completely your choice. And in this case, if I'm trying to remember, it looks like I made them both to -6. So if I want to get this to be the same over here as -6, this is going to become smaller, right? And if this becomes smaller, because negative 6 is smaller than negative 5, then this 6 has to become larger. Now remember, the 6 basically has like a decimal point right there, right now. So instead of it being 6, once I move that decimal, it's going to be 60 instead of 6. And our coefficient is going to become smaller. Now it's very nice right now because these two exponents are the same. So now all I have to do is combine my coefficients together. And our powers of 10 just stay 10 to the negative 6. So 60 plus 2 is 62. But again, this is non-scientific notation. This is going to need to get a little bit smaller, which means our power of 10 is going to have to get larger. So this will become 6.2, which means we move the decimal over once. And so this is going to become 1 larger. So 6.2 means it got smaller, our coefficient, but our exponent got larger, so it became 10 to the negative 5th. All right, so we're almost there. Let's try some with subtracting. I know it's a lot of examples, but I want to make sure you guys have plenty to look at. Okay, so one with subtracting. Exact same process as adding. The first thing we need to do is get them to be the same number. And what we're going to do is let's get these both to the power of 6. So this one, our power of 10 is going to have to become larger, which means our coefficient is going to become smaller. So we just move the decimal over once, and then we move this exponent up. So instead of 6.8, we have 0.68. Instead of 10 to the 6th, we now have, 10 to the 5th, we now have 10 to the 6th. This became smaller, this became larger. Again, we just combine our coefficients, and our powers of 10 combine just to stay 10 to the 6th. Once we subtract, we get this number, and it's perfect. This one's really nice this time because it's already in scientific notation. And again, I'll clarify on whether, oops, I don't know why that changed. Ignore this part down here in a second. But this one is actually perfect, and it is done. And I'll try to clarify on the homework whether or not to use, whether you need a round or not. So ignore this part down here. I'm not sure why that's added in. Okay, see, it's like it's never there. Let's look at one with negative exponents. So let's get these to be the same, and let's move it to negative 8. Honestly, you can go either way. You can make it smaller or larger. So if I want to make this one smaller to match the negative 8, this one needs to become larger. Our coefficient needs to become larger. So instead of this being 5, now it's going to become 50. And instead of this being 10 to the negative 7, it's going to become smaller, so it's 10 to the negative 8. Combine your coefficients, and then combine your powers. 50 minus 3 is 47, times 10 to the negative 8. Unfortunately, this is not in scientific notation. We know that this needs to become smaller. So if I need this to become smaller, our coefficient, then our exponent is going to need to become larger. So now I've got 4.7. Now it's going to be 10 to the negative 7th because negative 7 is smaller than negative 8. So it's all about moving those decimals and those place values around. Okay, now this is the last thing I want to show you, and then we are done. Let's say all the last few examples on adding and subtracting make no sense to you. Okay, you're looking at this process, and this is example number 5. I'm just showing it to you one more time again. Let's say that this process is just kind of totally making no sense. Okay, another method you can do is you can put it in standard form first. So what I mean by that is take this number and put it in standard form. Okay, so if I put it in standard form, this becomes 3,480, which you guys should be familiar with this process because that's what we did in the last notes. So remember, we take 3.48 and we say, okay, there's got to be 3 numbers after this decimal, and then this just becomes 3,000. I can change this to standard form as well. And then from there, those are simple numbers, and you just need to add them together, and you get 101,480. And then from there, you just put it back into scientific notation. You say, okay, I know my number has to be between here. So that's going to become 1.0 01480, which is really long right now, times 10 to the, well, there's 5 numbers here, so that's going to become to the 5th. And then if I round it, it just becomes 1.0 times 10 to the 5th. I think that's a really easy method, but I think it does take a little bit more time. And it does take probably more calculator use sometimes too. But if you are not liking the method that I've shown you on the last few slides, what you can do is you can use this method, change everything to standard form, and then change it back to scientific notation. Okay, so that is it. You have 4 practice problems, one on multiplication, division, addition, and subtraction. Give those a shot, and if you have any questions, let me know.